Okay, so now we're going to be covering electric work and power. So work, in its formal definition, is the capability to, to convert energy into motion, capability to convert energy into motion. If we do work over time, we create power, which is, work over time. And these are the formal definitions for work and power. In the scope of circuits, in order for us to do electric work, we are trying to put a source to dissipate or to kind of force electrons to move across any medium, whether it's resistive, capacitive, or inductive. And we are going to then dissipate that or store it in terms of energy. A related quantity to this then would be in the case of power, where since we'll find out that capacitors and inductors, when paired up with resistors, follow a kind of exponential pattern. So we must kind of quantify it also with respect to time. Now, later on, we'll cover why this convention is the case, but work is formally denoted as plus minus QV. This is the charge times the potential. Now, why is this quantity plus or minus? First, plus means that we have work absorbed or work released. Now, the only elements that can absorb would be resistors, capacitors, and inductors, or otherwise known as passive elements. For released, this would have to come from independent sources, things like batteries, which supply the voltage. But we don't like this definition to stay, mainly because it doesn't describe to us too much about the dynamics of it. So we like to quantify it in terms of, instead, the derivative of work over time. Similarly, this indicates power absorbed, or this indicates power delivered or released. And the integral derivative relationship, as we might have seen in the last video, follows this relationship. Now, the idea here is passive elements will always absorb power. It might not be that it will turn into heat like it would be in the case of real power or average power, but it will be probably stored in terms of energy, as in the case of an electric field from a capacitor or a magnetic field from an inductor. And that's where we might need this assignment of polarity. And that's just the main idea of electric work and power, just to show that we do need it as a quantitative measure to understand the differences between elements that store or elements that give energy and power and elements that take energy and power. Okay, thank you.